All right, so the concept of a function is the idea that you have a machine where you're plugging something in, an input. You're going to plug it in into the function, and then you get what we call our output. For the domain, the set of domain and ranges in a function, your domain is your input value. It's a set of all values that you're going to plug in, basically your x values on an ordered pair. So when we talk about ordered pairs, we talk about the concept of x comma y. What the x value is considered to be our domain. Hold on, let me pause for a second. All right, sorry about that. So again, our domain is going to be our x values, what we input. Our range is the output, the answer that we get when we plug an x value in. It's the y value. Now you'll notice these keywords that I have here as well. Domains are your independent variable, mean that they aren't affected by anything. Your domain has no effect to itself. The range is a dependent variable, which means that your range value, the output that you get, depends on the input that you plug in. So the solution that you receive will be determined by the value that gets inputted into the machine itself. Okay? So domain is your independent value, your range is your dependent value. So again, let's go ahead and mark that here. This is your domain, what you're plugging in, and this is your range, what you're receiving back. Now the function itself is just how each of your domains and ranges relate to each other. And it's the concept, if it is a function, it's the concept that a domain is paired up with exactly one range. Meaning, in this situation, if it is a function, the domain cannot repeat. That means that your domain can only have one range value. It cannot have more than one range value. Okay? If it has more than one range value paired up to a domain, meaning like, oh, if I plug in, you know, y equals x squared, the value of 1 can relate to only one value, right? The value of 1 can only relate to a positive 1. Okay? Does that make sense? Okay. Here, we have f of x is equal to 15x. F of x is equal to 15x. F of x is read as the function of x or f of x. Okay, it's a function of x or it's f of x. This is, again, this part right here is your range. This portion is the range. This portion right here, that's the domain. Okay? The domain is the x value, which happens to be a real number. X happens to be a real number. So we want to solve each function for the given domain. So if I've got f is equal to f of negative 3. So function of negative 3, if f of x is equal to 2x plus 1. What we want to do is we want to substitute in, instead of having an x, we're going to replace it with a negative 3. So our problem is 2 times x plus 1, but we're going to replace the x with the negative 3. So what's 2 times negative 3? Negative 6. And then what is negative 6 plus 1? Negative 5. Okay, so our value here would be negative 5. I want you guys to do the same thing for the rest of these, except replace this. I have a space here because my fraction didn't come out very nicely. So put a 1/2 in front of that x. That's got a coefficient of a 1/2. Go ahead and work out these problems by yourself, please. All right, let's take a look at this. We want f of 2 if f of x is equal to x minus 4. Who can raise their hand and tell me what is the value going to be if we substitute 2 in? Really, nobody can do that. Yochan? -2. You guys got to wake up, okay? You're just substituting the value of 2 in for x. So it's going to be 2 minus the 4. 2 minus 4 is going to come out to -2. Okay, what about for problem C? We have f of 11. If f of x is equal to 1/2 of x plus 5, what are we going to get for that, Bridget? 10.5 or 10 and 1/2. Again, you are substituting this 11 in for the x. So instead of half of an x, you're going to do half of 11 plus the 5. Half of 11 is 5.5, and then 5.5 is 10.5, or 5.5 plus 5 is 10.5. So you should get 10.5 for that value. Okay. Then we've got problem D. F of -6, if f of x is equal to 3x plus 4, what do we get for that one, Alex? -14. Very good. So we're taking that -6, we're replacing the x with a -6. So we're going to do 3 times -6 plus the 4. 3 times -6 gives us -18. -18 plus 4 comes out to -14. So there's our solution. You're just evaluating the values or terms of x into your function. Remember, again, your x values are your domain. The answers that you get are your y values. Those are your ranges. Okay, so the domain is -3, the range is -5. The domain was 11, the range was 10.5. Domain was 2, the range was -2. And for here, domain was -6, the range was -14. Okay? Yes. Problem C. So you're just plugging it. So did you put this 1/2 here? You need to do that. Remember I told you my fraction didn't come up, so you need to write it. So you're doing half of your x plus your 5. Half of the x plus the 5. So half of 11 is 5.5. 5.5 plus 5 is 10.5. Okay? All right, go ahead and flip it on over to the back. So for here, we're filling out these function tables. Your function table indicates the domain, the rule that's being applied, and then the range that you receive. So for here, when we're looking at these functions that are given to us, the rules are basically the expressions. So the rule in this case is x plus 5. Your rule in this case is going to be x plus 5. So that means when we fill out our rule for our function table, we're replacing the x with whatever the domain is going to be. So I'm going to go ahead and give you guys the values of your domain. We're going to let the domains, and it's always a good idea when you're filling out a function table, you should always have negative values, 0, and positive values for your domain. It gives you a good idea of the pattern that will follow. So I'm going to go ahead and pick out -2, 0, +2, and we'll say +5. -2, 0, +2, and 5. So we're going to replace our rule. Instead of x plus 5, it's going to be -2 plus 5. It's going to be 0 plus 5, +2 plus 5, and then 5 plus 5. Okay, when we fill that out, -2 plus 5 comes out to a +3. 0 plus 5 comes out to a +5. 2 plus 5 comes out to a +7. And 5 plus 5 comes out to a +10. That's our function table. Okay, so I want you to do B and C on your own. Again, I'm going to give you the domain and ranges. We'll just use the same domain and ranges that we have here. So -2, 0, 2, and 5 for our domains. You're going to fill out the rule, so identify what the rule is, fill out the rules pattern, and then what are the range values for each table. All right, for problem B, what's the rule? X minus 7. Okay, so the rule is x minus the 7. Okay, so when we plug that in, that means that we're going to be doing negative 2 minus 7. We're going to do 0 minus 7. We're going to do positive 2 minus 7. And we're going to do positive 5 minus 7. What is the range value going to be? The first range value, what is that? Negative 9. What about the next one? Okay, next. And the last one. Good. All right. What is the rule for the next problem? 4x minus the 1. Okay, so our rule is 4x minus the 1. Okay, that means that we're going to do 4 times negative 2 minus 1. We're going to do 4 times 0 minus the 1. 4 times positive 2 minus 1. And then 4 times 5 minus the 1. So let's fill in our ranges. What's the first range going to be? Negative 9, right? 4 times negative 2 is negative 8. Negative 8 minus 1 is negative 9. What's the next one? Negative 1. 4 times 0 is 0. 0 minus 1 is negative 1. Next one. Positive 7. 4 times 2 is 8. 8 minus 1 is 7. And then the last one. 19. 4 times 5 is 20. And 20 minus the 1 is 19. Okay? So range is what you're plugging in. Those are your x values. Domain, or sorry, backwards. Domain is your x values. It's what you're plugging in. Range is those y values, the output that you receive. Okay? And again, remember that your domain values are your independent and your range values are dependent, meaning that your range is determined by whatever your domain is. So looking here at this, if we've got a word problem or a real-world situation, approximately 770 peanuts is used to create a jar of peanut butter, right? So the total number of peanuts, P of J, okay, that's a function, is a function of the number of jars of peanut butter. So P of J, P of J is the range. The J is the independent value, the domain. Okay, so identifying our independent and dependent, that means that your independent is going to be the J, your dependent is going to be P of J. J represents what? Jars. So the number of jars that you are creating is going to determine how many peanuts you will need to create those jars. Okay, if I want 1 jar, I need to have 770 peanuts. Okay, so my independent is jars. My independent value is the jars. My dependent is the peanuts. How many jars of peanut butter that I want to create will determine the number of peanuts that I need based off of the way that we wrote the function. There's other ways we could reverse it. We could say that it's a function of peanuts will create the number of jars. It depends on how the problem is written, so you have to understand that. I could say instead of P of J, I could say it's F of P. Function of P. Function of peanuts will equal the number of jars. Okay, so it's all about how the function problem is written. Be mindful of that. So what values of domain and range are going to make sense for the situation? The types of values. So asking yourself this, jars, the number of jars. Can I have negative amount of jars? No. Can I have fraction jars? No. Can I have decimal jars? No. So rational numbers, not going to work. Integers, not going to work. Only thing that's going to work is whole numbers. You could have 0 jars, you could have 1 jar, you could have 2 jars. So it's just going to be whole numbers. Only whole numbers will be used in this situation. And if you can only have whole number jars, that means that they're only going to be using whole number of peanuts as well. Okay? Now, writing the function to represent the total number of peanuts that we will get. Writing the function to represent the total number of peanuts that we're going to get. So we know that the function is p of j, where we're going to do something to the number of jars to figure out the total number of peanuts. What do you think that we're going to do to the number of jars? What do you think the rule is going to be? Multiply them by what? Which whole number? Look at the problem. 770, right? There are 770 peanuts to a jar. So if I had 1 jar, it would just be 770 peanuts. But if I had 2 jars, I need to do 2 times 770. Or 3 jars times 770, and so on and so forth. So the function of the jars is equal to 770 times the number of jars. So using this function, how many peanuts will we need if there are 7 jars of peanut butter? So instead of p of j, it's going to be p of 7, a function of 7, which will equal 770 times 7. So what's 770 times 7? Go ahead and do that. You should have your calculators out. Huh? 5,390. Good. So 5,390 peanuts is needed for 7 jars. And again, the peanuts happens to be the range. The domain is the number of jars. Any questions? Okay, so you guys are going to have an assignment today. You've got a lot of time to be able to work on that assignment. You've got about 20, maybe 25 minutes of class time before we start Pride. Okay, so plenty of time to be able to work on the assignment. Let me go over some things that you need to make sure that you understand with this assignment, because it's very important for you to understand. You are going to be filling in different pieces of information here. You'll be doing evaluations just like we did at the beginning. You'll have function tables that you're also going to be filling in. You need to make sure you fill it in just like we did with the function tables here, meaning you have to place down what the rule was and what is the range. So you'll have your rule, you'll have your range values. I already gave you domain values. I gave you values for your domain. Now please make sure you understand this here as well. You have to tell me which values are your domain and which values are your range. You have to fill that in order to be able to be at full credit. So for example, problem number 4 is going to be worth 6 questions alone, because I want to make sure you have this column filled out correctly and that you have properly indicated your domain and that you've properly indicated your range. 6 questions alone for number 4, 6 questions for number 5, 6 questions for number 6. If you don't do those questions, that's a huge chunk of the assignment missing. Okay? Make sure that you correctly identify independent and dependents for each of the problems. Remember, again, whatever is set up, like so P of G, they're using P instead of F, but P of G, that's the range. G would be the domain. So remember to correctly relate those to independent and dependent. Okay, and then identify what types of values would be proper usage. Okay, looking back here, I've crossed off some problems that you don't need to do, but But here's what I want you to really focus on, because this problem in the past has been the one that has created the most issues. You should not have an identical answer to anybody else, because there's an infinite amount of possibilities. So if you have an identical answer to somebody else, what does that tell me? You copied off of somebody, or somebody copied off of you. You should have a different answer. Everybody needs a different answer. Now, I'm going to show you how to do one of these, but you should not have the same answer as me. If you've got the same answer as me, you will get in trouble. Don't copy my answer. But here they're saying that the function of -3 is going to equal to -8, meaning that when I plug in a domain of -3, I'm going to get a range value of -8. I need to create a rule, and then I need to draw a table where I show 0, a negative number, and a positive number as my domains, and fill out the range for that. So for this situation, I'm going to say that my rule is going to be 2 times x and then -2. Because if I do 2 times -3, 2 times -3 gives me -6, and then -6 minus 2 gives me -8. That's just one possible rule. Again, there's an infinite amount of rules that you could come up with. You could have multiplication involved. You could have addition involved. You could have subtraction involved. You could have combinations of those. You could have exponents involved. There's so many different ways that you could create a rule to where you are manipulating -3 to equal -8. So everyone should have a different answer. After you work that out, you should then have a table that you would draw. Where you are plugging in a 0, a negative value, I'll just pick -1, and a positive value, I'll pick +1. You would write down your rule, and then very quickly you would find out what your range would be. If I have 0, 2 times 0 minus the 2 would give me a -2. 2 times -1 is -2 minus 2. That would give me a -4. And then 2 times +1 is going to be a +2. 2 minus 2 would give me a 0. So I will have a different range or different table set up than everybody else. Okay, this is a problem that everyone should have a different value for. I will personally be collecting those and checking them. Okay, you will not be checking that as a class. I know we usually do it as a class whole. I will be collecting this independently as its own little assignment because it's an abstract thinking. Okay? And the rest of it is very basic to pretty straightforward stuff. Again, I've already written down what your domain values are going to be, or your input values are going to be. You just need to fill out the rest of the table. Any questions? Okay, let me get the assignment to you.